All right, so I'm using our subnet as an example to demonstrate how we do not need to calculate the range that we use, our first IP, our last IP, but we just need to understand the idea behind it. I'm sure we noticed that when we were creating our VPC and our subnet, when we enter the block that we want, let me do that again. When we enter the block that we want, AWS gives us like a picture into the number of IPs that we would be getting in that case. So we used and a VPC cider cannot overlap with another VPC cider block. So when we were doing it earlier, we saw that so depending on the inputs you give it, it will compute to the right the number of IP addresses that you can have. I think we saw this when we were doing the subnet. So one time it was 65,000 with the first subnet that we did and then terminated. And then the next it was 256. So when you're creating the VPC, AWS also helps you to get an idea of the kind of IP range you'll be using, but there are also resources. So for this subnet, for instance, this is the CIDR that we use for it. So when you come and put the CIDR that you want inside this tool, it will be able to get you your net mask, your CIDR base IP, the broadcast. We said the broadcast is the last IP in the network, and it will also tell you the number of IP addresses you have available when you're using this mask. So the first usable IP, the last usable IP entered 254 because the 255 has consumed the broadcast IP. And then the net mask shows us the parts that are blocked. So this inside our subnet, for instance, this is the network mask. Those sites or that part cannot change. And then the CIDR base IP is the first network or the first IP address inside that network. That's the CIDR base IP, which is the IP address of the subnet. And this tool too does a similar thing, or it does the same thing. So I calculated the one for the VPC earlier. This is a VPC CIDR here. So it shows us that VPC would be able to, the way we've configured our CIDR block, we can get 65,000 IP addresses from there. And it shows you the network mask, shows you the wildcard bit has to do with the host. So the host IP addresses, that's the wildcard bits in this example. And then the net mask has to do with the network. So we mentioned that the network and then the host depends on the number of bits that have been blocked. Your first IP, your last IP. So that's the CIDR for VPC. Subnet is this one. So calculate that to, and here we can see that for our subnets, the wildcard bits we can have 255, affording us 256 total hosts. And all here is blocked. So it's the same idea. So knowing how to calculate it or coming to calculate it here before going to provision it inside your console is the way to go. You just should understand what is happening behind the hood, but you do not always need to calculate it by yourselves. Okay, we can start with additional networking protocols. Who remembers the two networking protocols that we've already looked at so far? We looked at them, say yesterday. Dennis.
The TCP/IP and UDP.
Thank you, Dennis. So today we are going to be looking at additional communication protocols. When we talk about communication protocols, the rules that come into play or the standardizations that have been put into place to make sure that data transmission or communication over a network is able to take place in a standardized way. So we'll be looking at the transport protocol, application protocol, and then the management and support protocol. The transport protocol are the ones that we have already seen. We have the transmission control protocol and then the user datagram protocol. We spoke about how the TCP is connection oriented. So and the UDP is connectionless. So it makes the UDP faster than the TCP. But one disadvantage about the UDP is that you cannot guarantee that your message will be delivered, and you cannot guarantee the order in which the receiver gets whatever data you transmitted. And for the application protocol, we have HTTP, SSL, TLS. We'll get into those shortly. And for the management and support protocol, we have the DNS, file transfer, DHCP, and ICMP. So we use the ICMP protocol earlier today, but if we've been paying attention, whenever we go to our security group, the list of ports there that we can open, and there's also a protocol that corresponds. So you notice that when you select a port 18, the protocol that will correspond to that port 80 you selected would be HTTP. When you select a IDP, what would correspond would be 3389, those things. So that's what we're looking at, the rules that permits the communication between the systems. So for example, when we were communicating or when we were connecting from our local machines to our EC2 instance, so that's communication, how the information is transmitted to us. So in that case, we used SSH. Okay. Okay, we've looked at the two transport protocols, and for the application protocols, they take care of the processes from downloading a web page to sending an email, etc. And the management protocols are used to configure and maintain network equipment. So we met the OSI model again, and we mentioned that the OSI model just is a standard way for computers to share the data or to transmit whatever data over a network. And it came about because of the multiple vendor system. So people were creating hardware and software for networking, and then there needed to be a standard, something that they all should follow, so that even though your company is Cisco or your company is some other hardware or software company that is making infrastructure for data transmission or for networking, you would still have to follow these protocols for your networking activities to be able to be successful. And we looked at the 7 layers. I think yesterday Dennis took us and mentioned all of them. So the transport protocols, the TCP and UDP, they are, when an issue is encountered with them, you know that it's most likely a layer 4 problem, which is the transport layer of the OSI model. And issues include access control lists or firewalls that are blocking these TCP UDP ports. So firewalls include the security group acts as our firewall inside of AWS. Okay, so we're getting deeper into TCP. It's connection oriented. You need to establish a connection before the applications can exchange any data. And then the data is divided into smaller chunks called packets. I mentioned how things that or features that packet carries is the source IP, the destination IP, the message or the data being transmitted. So that happens at that is carried over the network. The packet is carried over the network. So in this case, when the connection is established, then that is when the packets are able to be exchanged between node A and node B. And the whole internet runs on the TCP/IP protocol suite. UDP is simple and connectionless and also unreliable in the sense that there's no guarantee of the order of the data, or there's not even any guarantee on if the data is going to be delivered at all. And an example we gave was for streaming services. They make use of the UDP because it's faster. Okay, so TCP versus UDP side by side. Who can tell us the difference or mention one difference between TCP UDP? Terry.
Hello, madam. So, so TCP is a connection-oriented protocol, whilst UDP is connectionless.
Thank you, Terry. Derek.
Okay, so TCP is a reliable protocol, whilst UDP is unreliable protocol.
Thank you.
The
Osman.
UDP is faster than TCP.
Yes, the
So
UDP is
the
faster.
UDP is faster than TCP.
All right, thank you, Osman. Okay. Well, likely the connection, Emmanuel Auku.
Oh, that's fine. I think I wanted to add to the TCP
UDP, okay.
UDP earlier.
Yeah, you can go ahead.
All right, I just also wanted to point out that the TCP is used for file transfer, emails, and other scenarios where reliability is crucial. Speed matters when you are, let's say, video streaming and playing online games.
Okay. Thank you. So with the network protocols, there's a connection-oriented protocol and there's also connectionless. And we know what that means. And we also looked at it being synchronous. So the connection one is synchronous, as in the exchange is happening at the same time. So as the sender is sending, the receiver is also receiving it and sending back the transmission. And the connectionless one is asynchronous in the sense that the sender has to send, and then the node B or the receiver would receive after whatever transmission has been sent. the TCP handshake. So because it's connection oriented, these are the three messages that go between the sender and the receiver. So the sender sends the sync, and then the receiver acknowledges that yes, they have received the sync, and that's when the whole connection process or the connection session begins. Application protocols have the HTTP, and that is what is used to reach web pages. So when we visit websites, we notice that sometimes we have yeah. So for example, we would see, depending on the websites that we're visiting, we would see HTTP or we would see HTTPS. The difference is that the HTTPS is secured, so it has encryption present. We've spoken about encryption before, about how it's just making readable data unreadable. So if somebody doesn't have the encryption key or someone doesn't have the resources to be able to decrypt whatever message it is, then that application or that person will not be able to make sense of whatever data they are looking at. So that's the difference between the HTTP and the HTTPS. The HTTPS is secure because it has the SSL TLS protocol. We'll get deeper into that later. And the HTTP address is represented by URLs, the Uniform Resource Locator. So we are able to click on a link and then it takes us somewhere. That is the link is locating the resource that we are searching for. And it's universal in the sense that no matter where you're connecting from, when you use that link, it will bring you to that resource. So universally, that resource owns that link, or that resource owns that location. So when you use that URL, it should bring you to that resource's location. So when you combine HTTP with the SSL TLS protocol, then you have HTTPS. And the SSS TLS is a standard way of securing and safeguarding communications between two systems by using encryption. So sometimes it would be advised that when you visit a site and then it doesn't have, like it has just HTTP and it doesn't have the HTTPS, you should be careful of the information or the kind of transactions you perform on that site. Because what's happening behind the scenes is that when a company, for instance, tries to get an SSL certificate, so this certificate to show that, okay, yes, this company obeys the standard way of making communications or making data transmissions over the internet. To get that certificate, they would usually have to put some information about them. So in that case, you can be assured that whatever encryption or whatever requirements that the site needs, they have it, because if anything should go wrong, there's a person or there's a party that can be held responsible. So the compliance or the more serious organizations would usually use, or oftentimes they will find them using HTTPS. That just shows that they are compliant with these SSL TLS rules. So TLS is an updated version of SSL, and that is more secure. But you usually hear them being used together, SSL TLS, SSL TLS. So it creates a secure channel between the user's computer and then the other device. So you know that whatever data you're transmitting is going straight from your computer to whichever server they are trying to transmit it from. There's no way middlemen or anything would intercept and steal that data. So during the TLS handshake, the two sides exchange messages and they acknowledge each other. So when they verify each other, they agree on the encryption, decryption process to take to be able to encrypt whatever data they are going to be sharing between each other. So encryption, authentication, and integrity. So if the data is being transferred from any third parties or any interceptors, it would hide it's from that party. So it's just between the two parties. To provision and manage your public and private SSL TLS certificates, you use AWS Certificates Manager. So AWS Certificates Manager is a way for you to get a certificate for your website. So for example, you just use an HTTP website, but you know that HTTPS is more secure due to the encryption feature it offers. So you can use this service called AWS Certificates Manager to help you provision and manage your an SSL TLS certificate for your website or for your business. I think to configure one, we'll need some information from you, address, the website, those things. We'll look at Certificate Manager too. Mail protocols, SMTP, POP, and IMAP. SMTP is used to transfer email messages between mail servers. And what POP and IMAP do is to retrieve those messages. So for example, you send an email from, or I send an email from East Legon where I am, and then it goes to a server to around where whichever receiver is. And then through the POP and IMAP, the retriever or the receiver is able to retrieve that, or the person's computer or the node is able to retrieve whatever email that has been sent to the mail server. So that's what these mail protocols to do. And remote desktop protocols. They are used to remotely access machines and other servers. So for example, my Windows machine that I have here, I need something done on it, or I need some configurations done, but I might not be able to do it, or I do not have the expertise to do it. Someone somewhere can use the remote desktop protocol. It's a software that you download. So he would download, I would download, and after a few other configurations, the person should be able to use your machine as if your machine is with them wherever they are. And that is also one good function of the cloud, because when we borrow, so for example, when we borrow a Windows machine from AWS, we use RDP to be able to control it or to be able to use that machine. So we are here in Ghana, but we borrowed a Windows machine from in US East 1, and we are able to use RDP to have that machine work just like if that machine was with us here in Ghana. And then SSH2 is also used to access Linux-based servers especially, but that's also another way of remotely connecting to another computer or remotely connecting to another server or machine. So with SSH, we've seen that it takes you straight to the CLI, but with RDP, the last time the Windows machine, it took us to, okay, I didn't demonstrate that, but RDP would have taken you to the GUI of the Windows. So the way when you open your computer, you see your desktop with your files and then your taskbar. That's what if we had provisioned a Windows machine in AWS, that's what we would have seen. And you could also use SSH for Windows machines because there's a utility. So after Windows 10, Windows 10 and later, there's a utility called OpenSSH. So you will be able to use an SSH client. You use the OpenSSH as an SSH client to access a Windows server. So both RDP and SSH are used to remotely access machines and servers. And they are a secure way of accessing cloud-based servers. And they also help remote employees in using infrastructure on-premise. So for example, you're working from home today and you need to access some infrastructure that is in the office. RDP or even SSH could help you to do that. So the application protocol port numbers for HTTP, we have 80, HTTPS 443, file transfer protocol 21, SSH 22, and DNS 53. Who remembers the name of the DNS service that AWS has, or that's AWS Office? Yakubu.
Route 53.
Thank you, Yakubu. So that is where the name, or that's where the number 53 is from. That's why it's named Route 53, because the ports responsible for DNS inside your server is the port 53. So yesterday I mentioned how even though we must be, or even though your users or your infrastructure guys are connecting to one server, the endpoints that they go to meet is what the port number controls. So if maybe users of your website or users of your app are trying to access your server, you would usually give them an 80 or so you should usually have them go through port 80 or port 443 because it's likely that is your web page that they would be looking for. But if, for example, your cloud engineer wants to also access the same server, he would go to port 22. So that's the idea behind port numbers and the application protocol. Let me open the EC2 again. So you're able to control traffic, or you're able to control the traffic that goes to and from your server or from your instances. And you're able to, you do this with the security group. So you define some inbound rules on what traffic you want coming in, where you expect that traffic from. And so for custom TCP, that's when you have a particular port range that you want to use. This, you can also see the other protocols that we've mentioned. So depending on what's need that you have for your server, for example, when you're connecting your database server and your web server, you'd likely go for, dependent on the engine you're using, but then you'd likely go for this one. SQL, there's my SQL Aurora. Yeah, I go for my SQL Aurora. I know my SQL is a really popular database engine, so you'd likely go for that. So depending on which endpoints that whoever is accessing your resources needs to go and meet, that's the port and its corresponding protocol that you would select. Most of the application protocols fall under the application layer of the OSI model. So HTTP, FTP, POP, SMTP, and DNS. So the management and support protocols. Examples include domain name system, ICMP, DHCP, and FTP. So they are used to manage your network equipment. Yesterday, I think John Helbert spoke about the DHCP, how it assigns IP addresses to your resources. So we get deeper into that. So these are the examples. We start with DNS. Yesterday, I demonstrated how we would enter google.com into our browser, for instance, but how the DNS server is interpreting it is with an IP address. So that set of numbers, usually an IPv4 address. So I think yesterday the one we looked at was like 172.something.something, but it leads to the same place. William has told us before that a DNS server is just the phone book of the internet. So you give it the name, but then it calls the number. So you give it the human readable name, and then it goes to give you the machine readable IP address so that you're able to get to whatever website or get to whatever resource that you're trying to access. Okay. And the second protocol and the management protocols is the ICMP. We looked at the ICMP earlier today, and it's used to diagnose your network communication issues. And one command under the ICMP is the ping utility, and you can use the ping utility to send a request to call it an echo request. So send the echo request to your server. If your server is able to respond back, then we know that your server is up and running. But if your server is unreachable, then you get an error message. Today we got an error message after we closed our security group. I'm sure you guys remember. Then DHCP, that automatically assigns IP addresses, subnet marks, gateways to the devices that are connected to a network. So for example, I come into the office and I connect to the office's network. The DHCP server assigns me an IP address, subnet marks. I think today we didn't run it, but when we saw the picture where someone had run ipconfig, so all that's information. So if I should need something from the ISP, the DHCP has assigned me a default gateway, which is acting like a router. So that will be able to get me internet access. So it's the DHCP that would assign me a default gateway to also assign me an IP address as so I can be identified on the network. And examples of the options that DHCP assigns you are the default gateway for internet access, the DNS server, and then the DNS domain name. Yakubu.
Yeah, so for the DJCP, earlier this morning we did when we were setting up the VPC, you said the VPC and more, it sets up like you don't have to set all the settings. It sets that automatically. So does it mean that the VPC and more is a DHCP?
The things that we said the VPCMO will do for us, they included getting the internet gateway, making the route to the internet gateway, and what else, guys? So those things that we did this morning, that is what the VPCMO will do for us.
So that's, yeah, so setting up the NAT gateway, setting up the subnets, setting up the network ACL, setting up the security No, that one is the instance.
Yeah, and the
So-
network ACL2, it comes automatically with the subnet. So this is what the VPC and more will do for us. So our subnets, our route tables, and then the gateways or the resources that we need on that route table. Sorry for that
Oh,
VPC.
okay, so it does not assign IP addresses.
The VPC would assign IP addresses. So when you provision a resource inside the VPC, it would assign IP address from the pool that you have.
Okay. Okay, so it will assign IP addresses from the CIDR range that you provided.
Yes.
Okay. But then the DHCP, I don't sorry, what exactly does it do? Like,
But we were asking about the dynamic assigning of the IP addresses and those things. So whether
okay,
we
so
go with the VPC and more, or we just go with the VPC only and do our configurations ourselves, our resources will still be dynamically assigned IP addresses.
okay. Okay.
But we
So
won't
that
do the
means that
assigning by ourselves.
okay, so that
Pardon? Oh, my internet's gone off.
hello.
Hello, Yakubu.
Yes, hello.
Here, you were saying
So,
something.
so I was saying that so does it mean that like all networks comes with DHCP or is provided by the internet provider?
So our VPC network, for instance, yes, it does have its DHCP. So I believe other networks that we sign on to also have their DHCP way to assign that assigns their IP addresses.
Okay. Okay, all right. Okay, thank you.
You're welcome.
Okay, so let's say that for the traditional networks, let's say that maybe you are connected to your Wi-Fi with your laptop and your phone.
Mm-hmm.
So a DHCP assigns the IP address to the laptop and the phone.
Yes.
Okay. Okay. So that means that the DHCP is being provided by the internet provider or the Wi-Fi.
Yes.
All right, thank you.
You're welcome. The FTP protocol, it authorizes the transfer of files from one computer to another, and the basic two functions are put and get. So put could be like an upload, and then get could be like a download. So these are some network utilities that you can use when investigating information about your network performance, your bandwidth usage, your network configurations, just ensuring that things work, or sometimes even for troubleshooting, you can use these. So the ping tests the connectivity. So you are connecting to a remote device and you want to test if it is on the network or if it is active. You can use the ping utility for that. And then the NS lookup queries DNS and its servers. So when you run NS lookup with the DNS name, it will return the IP for you that is associated with a given domain name. And the trace route permits users to see the networking path that is being used. So you'd be able to see the hops. When we say hops, it's from one server to another. So the number of servers that your connection or your data traversed before it came to the receiving end. So you'd be able to use the trace route to see the path, the number of hops where it passed to be able to get to you. And telnet is used for service response. It tests whether the service is responding to requests. So the ping tests the service connectivity, and then the telnet would test a specific service that is running on the remote device. Who remembers the service that we installed on our server earlier this week? There was one service that we installed on our EC2 server.
Is it the Nginx?
Yeah, thank you. So you'll be able to use telnet to check a specific service that has been installed on your remote device. And the hping command also comes in handy when you're troubleshooting. So you want to know where your packet is what contains information about where the data is going to, the source, where it's coming from. So if your packet gets lost and your data is not able to be transmitted, or you're experiencing latency or delay issues, you know to run the hping command, because that's going to give you insight into where the packet was lost at. So before we can run these commands, we should have enabled enhanced networking on our instance. I was looking at the documentation for enhanced networking, and it's actually so I think I would just give it to you guys as an assignment instead. So you would enable enhanced networking on your instance. Let me provide the documentation. So depending on the OS, the instance or the instance AMI that you're using, that is what will determine the enhanced networking procedure that you go through. So after running the enhanced, after enabling enhanced networking on your instance, you should test out these networking diagnostic tools. There's a number of them. So the NS lookup, telnet, all of those. We've actually demonstrated ping already, so but then for the rest of them, so I would share a form so that you test them out and then upload screenshots of the results. And I would share the enhanced networking documentation. It's in the AWS documentation, so I will share that too on Slack. Yeah, so that's it for this module. Yeah, so after I receive the submissions, and then we do the checkpoints questions. Okay.
Oh, you call it a day.
Yes. Okay, so this is just a summary of the things we've said.
What's that?
Derek,
Yes. Are we doing it now?
no, not now.
Oh, okay. Because ECG has taken my power, so my laptop is off. I'm using my phone, that's why.
Oh, okay. So tomorrow morning, I should get it by tomorrow morning.
All right, sure. All right, thank you.
You're welcome. Okay, so we can move on. This is the last slide or the last module under networking.
Um, Akosia, please, could you repeat the assignment again? I didn't get it very well.
Okay, so I was going to demonstrate the various utilities. So NS lookup, telnet, MTR, and trace route, and HPing3. And before we can demonstrate them, you need to have enhanced networking enabled in your instance. So I'm giving it as an assignment instead. I would provide the link to the documentation on enabling enhanced networking. And when we test out the commands, we should send the results, take a screenshot of the results page and submit it to a Google form that I will provide after the session. Is that okay?
Thank you.
Pardon?
I, I said that's okay. Thank you.
Okay, you're welcome. All right, so onto the last module, we're first looking at wireless technologies. What do we understand by wireless? Guys, wireless. Dennis,
Basically,
don't tell me there are no wires.
oh, okay.
That's exactly what
Actually, I was
That's
coming to say
that's what I'm going to
Wait,
say.
wait, wait, now
Without wires. Okay, so
So
it takes us from the traditional setting where you need cords attached to the devices, and it brings us to a more cloud setting. So this place they said through the air. So for example, with your earpiece, for instance, when the traditional earpiece that we used to use, you have to connect the wire to your laptop or to your phone. But right now we have AirPods, which are wireless. So when we talk about wireless technologies, it's just about how we no longer need cords to be able to get whatever purpose it is done. So cars, phones, desktop computers, etc., we are able to connect or we are able to communicate with other devices without the need for wires. Examples include wired equivalent privacy, Wi-Fi protected access, Bluetooth low energy, and 5G cellular systems. So these are the technologies that are making communication responsible, making communication possible for us without the need of cords. Okay, has anybody heard about 5G?
Yeah.
Okay, can you tell us anything about 5G?
It is very, very fast.
Well, they claim it's an enhanced network, the 4G, which
Okay.
myself I don't believe we have, but sometimes they have it. So they say 5G is better than 4G. And uh, I mean, you have about 100 megabits per second of data transfer in and out. You use the network.
Okay. Thank you, Dennis. Who else? Richard
Akosia,
Romeo.
Akosia.
Good
Yes,
afternoon.
Joshua, you go after Richard, okay?
Okay. Oh, he will
Okay.
say mine. Mine is very simple. It is very fast.
Okay, 5G is very fast. Thank you.
Yeah, very fast.
Okay, so the little I know about the 5G network is I know the 5G is a fifth generation wireless technology. It is the latest, or let's say the advanced form of like technology used in cellular network technology.
Okay. Thank you, Richard. All right, so the way sometimes we are trying to access the internet and we can see from our phones, for instance, the maybe 3G or 4G, I think it starts or LTE or something. So all those things go into the kind of internet speed that you experience. So how fast or how quick you are able to get your data transmitted to you or data transmitted over the internet. And AWS is one of the services that takes advantage of wireless technologies. Then that's how come you can be here and then be able to access service around the world. Okay, does anyone know about Internet of Things? I remember this from our cloud computing first day. I spoke about Internet of Things.
Yeah, for sure I do.
Okay, Jesse, go ahead.
Okay, so what I know about IoT is such that you give let's say you enable an object such that it will be able to communicate or perform a task over the internet. Yeah, so let me give an example. When it comes to say home automation, you might say getting objects in your home, automate it such that over the internet it will be able to communicate or interact um with less than humans within that particular entry. Yeah, so that's basically what the IoT is about.
All right, thank you, Jesse. So when we talk about Internet of Things, it's just those other things. So apart from your phones, your computers, your laptops, those other things that also make use of the internet, your TV, some cars make use of Internet of Things. So it's just those other things or those other devices that are able to make use of the internet. So they are just physical devices and things that are connected to the internet. So they are able to share and collect data. And the primary goal is that they should be able to self-report in real time, which makes them very efficient. So these devices or these things by themselves are able to transmit data or are able to send data without the need for or with only minimal need of human intervention. and they have built-in connectivity capabilities, and they're also able to generate large amounts of data. So a lot of IoT devices are in homes, factories, hospitals, and the data that they transmit can be collected, stored, and analyzed to design better solutions or products. Our smartwatches, some toasters, industrial sensors, health monitors too. So some IoT devices that we use every day are smartphones, smartwatches, smart glasses, connected cars, thermostats that regulate the temperatures in our homes, for example. And enterprise IoT devices include medicine pumps, smart fleet management, CCTV cameras, smart cities. So the CCTV example is a really good example. So you could be anywhere and be able to monitor in real time whatever is happening somewhere else. Because thanks to the CCTV, the data or the video feed is being transmitted in real time to you wherever you are. So the sensors and actuators on the IoT device gather information. For example, you can capture the temperature of a room, which is some data or which is some information, and it is able to transmit that information, or it's able to show that information that by now your room is at this degrees. So the data is sent from the device to a device gateway, which pushes it to a cloud-based platform. So those of us who have used who have seen people monitor their homes from a CCTV, probably an app or a browser or a website, they're able to monitor their homes from that because the device is able to send real-time data to that cloud-based space. So when it gets into the cloud, and that's when you can also consume it with your phones or laptop or anything that you want to use to access the data. So the user interface is what helps the user to be able to utilize whatever device, the computer or phone, that is your window, or that is your gateway into the IoT world. Yeah. So we're going to look at AWS's IoT core service. It's used to connect a large number of IoT devices, and it's able to route trillions of messages to different AWS services. And you can choose the communication protocol that you want to use. So HTTPS, for example, you want to monitor the feed, what's it called? The CCTV feed through your browser. You want that data transmitted over HTTPS because that's what will be accessing it. And they communicate with cloud services by using Wi-Fi, cellular data, and other technologies and protocols to transmit this message. Enterprise mobility. It's the growing trend for businesses. It supports remote working options in which you use your personal laptops and devices or your mobile devices for business. You're able to connect and access data through cloud technology. And AWS has two services or two features that facilitates the enterprise mobility model. And it's bring your own device. And then there's also mobile device management. So when we talk about bring your own device, it's when you want to use your personal device, such as a mobile phone or a tablet, on a public or private network. And when we talk about mobile device management, it's not just about phones, like mobile phones, also applies to laptops and desktop computers. And they provide your device with settings, software for your device to be able to access data in a secure way that complies with their needs. Amazon Workspaces is a service in AWS which helps you to provision cloud-based Windows machines and Windows machines and Linux desktop machines. So you use either the AWS Directory Service or the AWS Directory Service for Microsoft Active Directory to authenticate the users. So probably inside your office, you use Microsoft Active Directory. Has any of us heard of Microsoft's Active Directory? Richard, Romeo.
Yes, I think that is what I use at my workplace.
Mm-hmm.
So it works like let me try and then break it down.
Okay.
So it works like should I say a virtual machine. So what happens is everyone at the workplace has let's say a login access to it, and whatever they do on their machine saves automatically on the server through the Active Directory.
Okay. Okay, thank you, Richard. So with the Microsoft Active Directory, you're able to log and monitor so each user inside the company, for instance, is going to have an account. So like the user accounts for them, and then the account specifies what they can and cannot do. So the network resources that are available to them. So on-prem, Microsoft Active Directory is used. So it's able to manage the users and then the permissions that they have to access the network resources. So according to their access or according to whatever they are doing, then their user or their profile is being saved. So when you want to move or you want to borrow Linux desktops and Windows machines from AWS, the Amazon Workspaces service affords you to be able to use that Active Directory on the AWS cloud. So you don't now have to come and set up all these like new users for each colleague or each employee, but you can just use the Active Directory service to authenticate the users and manage the kind of access that they have to the Linux and Windows desktops that you'll be provisioning. So Amazon Workspaces is just bringing your bringing your office, so your work, your office space, your workspace, so bringing it to AWS or bringing it to the cloud. That's what it affords you to be able to do. And you can manage and deploy your applications by using the Amazon Workspaces application manager. So whatever Windows or Linux machines, your desktop machines you're using are like they belong to AWS, but then you are able to use them just like how you use your machines in the office. And it's simple to manage because there are tools available, and knowing AWS, there's documentation. It's very well documented, and you're able to have a seamless migration when you want to move from using your regular workspace to using Amazon Workspaces. And it's also secure, just like the other AWS services, unless you go and configure something to expose yourself. By default, it's secure. And you can use encryption keys from KMS to also further enhance or to further strengthen the security of your infrastructure. And you also have the chance to control the IP addresses of the users that are allowed to access your workspaces. So you can restrict it that my workspace should only be accessed from users who are coming from my network. So we saw how you can block or you can group a number of IP addresses using the suffix, the CIDR block, the slash, and then the number. So when you represent the CIDR block with, when you represent the users that you'll be expecting or the network that you'll be expecting traffic from, then that's also an additional security feature, so that not anybody anywhere can access your workspaces. It's just meant for only the people on your network or the people in your company. Johnny Albert.
Hello, Akosia.
Yes, John.
I was just thinking about this Amazon Workspaces, and you said that it is like borrowing a desktop
machine
from
Amazon.
Okay,
Yes.
so somebody is sitting in Accra, they are running AWS services, and then they have borrowed a desktop from Amazon. How are they connected to the workspaces? And they're going to actually use another machine here to connect to the workspaces?
Yes, they will need another machine to connect to the workspaces, but it could be that they want a more high performance computer or a high performance machine, or they want to install some complex software that they would rather not use their local machine. So in this case, they'll just use their local machine to connect there, but whatever specs that they are looking for in the new desktop computer, instead of them going to buy themselves a new desktop computer, they would rather just borrow Amazon's desktop computer.
Okay, so then once they connect to the workspaces, then they can continue running whatever service they want to run. Their machine they use to connect is basically like a terminal device.
Yes, please.
Okay, okay. Thank you.
You're welcome. And you can workspaces too can also scale consistently. So with the more space that you need, you can expand whatever volumes. So in this sense, the hard disk you are borrowing, okay, so you're able to expand to be for it to house or for it to accommodate as much data as you need. And customers can request a volume expansion one time in a 6-hour period. Okay, these are other rules too that come with using Amazon Workspaces. So as I explained to John, for example, your whole floor, you need to work on a project, or you need to run some tests, and then whatever specifications that the computers that you have in your office, they have, those specifications are just not probably in terms of hardware, they are not probably your CPU that you use in your office is about Core i3, and then you want something more high performance. So that's when you will borrow a desktop computer from AWS using Amazon Workspaces. So you can create a workspace, and then your team or the people who need those specifications or who need that machine to be able to work would all join it. And then just like how you regulate the individual laptops in your office, so each computer that is assigned, so for my office, for example, each computer that's assigned, we have some network restrictions. We also have, so this user is assigned this machine, this user or this employee is assigned this machine. So you can take the Active Directory helps you to do that on-prem. So you can integrate that Active Directory into your workspaces, and it will also be easy to manage. It's just like how you manage it on-prem, but you're able to manage it in AWS. Gifty, your hand was up.
Yes, Apusia. After who Johnny Albert asked the question, so I just wanted to add up that the workspace, the Amazon workspace, it works just like the way IT admins can set group policies in our corporate like offices. Yeah, there are times that you realize that when you are a new employee and you are even assigned a PC, there are certain restrictions that the IT admin has to later make some configurations or enable certain settings, like some of the settings on the PC for you before you can use. You understand?
Yeah.
So like certain group policies at workplace, no. Whether at the user level or the computer, whatever configuration has to be done before for a new user. Yeah, I think it's the same concept with the Amazon workspace one. Those
Okay.
policies.
All right. Thank you, Gifty. So looking at some use cases for Amazon Workspaces, for example, employees who work from home or remote employees. So when you set up the workspaces, in that case, your whole or a section of your office or a section of your department is now cloud-based or is now remote. So all the employee needs is to get his browser and an internet connection, and then it doesn't matter the specs on his machine, because right now he's going to be using the specs of the machine you're borrowing, so he's going to be able to do all of those things. Another example too is for contract workers. So you might not want to buy a machine for a contract worker, especially considering they're not going to be, well, depending on how long they're going to be around for, but contract workers are usually temporary. So it might be more cost effective, or it might be better to have them join the Amazon workspaces instead than provision them a machine. And employees who work from multiple devices, including personal devices. So your employee, for some reason, your employee is working with a personal device, or he needs to work from multiple devices. You could use workspaces to facilitate that, and also for developers. After a merger or acquisition. Okay. So AWS offers a variety of workspaces bundles, so different specifications and hardware and different software configurations. So you specify the kind of machine that you want to borrow from them. Okay, so after a user launches an Amazon workspace, the end user can decrease the size of the routes or user volumes within the workspace. Does anyone know? Okay, so I said that you could increase the size, but it's not allowed, or it's not a good idea to decrease the size, because that could result in data loss. So when you're using Amazon Workspace, you're at liberty to, it scales out or it scales up. So you're at liberty to have your volume size grow as your storage needs grow, but to decrease the size, nope, because you would lose some data. So after a user launches an Amazon Workspace, you cannot decrease the size of your routes or user volumes, because ideally, let's say this is the size of the volume and you don't know where exactly, or which part of the volume exactly stores which data. So if you're going to reduce the size, you are bound to lose something, or you are bound to lose some files. So it's not a good idea, or it's not recommended. It's not even allowed to decrease the size of the root user volume. And then which protocol ensures that IoT devices can connect to the internet securely? The keyword here is securely. Which protocol ensures?
HTTPS.
Thank you, Dennis. All right, so the wireless technology, web WPA, the Bluetooth, low something. So it's 3:13. So I would let, that's all for today. That's all for networking. So I would let you guys go so you can catch up with the cases and labs, and you can also attend to their assignments. So those of us who don't have power, I hope by evening we would be able to get the work done, or we're able to get electricity back, and then we get the work done. So tomorrow morning when we come, we will discuss the assignments, and then after that we would proceed to start with security. And so we'll do introduction to security together, and then I would assign the topics for each group to go and do the research on. So for Monday is a holiday, so Tuesday then we start with the presentations. So each group should be ready on Tuesday. Yeah, it should be there's 6 groups, so a 10-minute presentation each, or 15 minutes. I'll put the instructions in in this document. I've actually started working on it, so all the information is going to be here, and then I would update it in Slack too. There you go. Who's to answer?
Yeah, I was here.
Hi,
Will you
Derek.
be posting the assignment on Slack?
Yes, I would. Wait, is it this one? Is it this one or the group assignment?
Both.
Both. Okay, so for this one, I'll just post the form.
All right.
Yeah.
All right, sure.
Ruben,
Oh, madam. Afternoon once again.
good afternoon.
I'm not all that fine. That's why, hear from me. But
Oh,
the little
sorry.
that I grab from it is, it's good that we are learning this course, and mostly I think we are just grabbing the most advantages of, for instance, AWS and the workspace, for instance. But I want to know, as we ought to learn in general terms, that what are some of the disadvantages of maybe using a workspace, for instance? Because I just want to know both sides, the advantages and the disadvantages, as we are in this technological world. If you get my point. Thank you.
You're welcome. So guys, after going through workspaces, can anybody tell me what they think a disadvantage of workspace would be?
Because yeah,
Yes, Gifty.
to me, I think maybe it might be expensive for a type of organization to afford. Okay,
Okay.
it could be a disadvantage.
Okay. So she's speaking about how it puts some organizations at a disadvantage because if you are not able to afford or if you don't have enough money or resources to be able to afford the workspace, then that means you won't be able to get things done. And another one too could be about so one thing about EBS volumes is that you pay for what you provision. So when we were provisioning an instance, usually the default is 8 gig. So you are paying for all 8 gig. And here is a situation where you can't reduce the size of your volume. So for example, if you didn't really plan properly or you didn't really guess right, and then you want to provision a volume that is over, for you to it's not possible for you to reduce it. So you're going to have to keep, it's two options. You're going to have to keep paying for the volume, or you're going to have to provision a new volume or create a backup. But the new volume that you provision, when you want to use the backup from the previous volume, it cannot be less. So if you want to back up your 1 gig, you cannot provision something less than that. So that means that is not even really an option. You just have to keep paying for volume that you do not need. Can anyone think of any others?
Okay, I also think training people can also be a difficulty, assuming I'm being trained for a company and then I leave the company, you have to also incur costs or take people to training on how to use the cloud.
Yeah. All right. Thank you for that, David. So AWS is, I don't know if you guys have noticed, but there are a lot of AWS resources out there if you want to learn to use the cloud. So there's Restart, which is the program you're in. There's AWS Educate, there's Skill Builder, there's the AWS community. So if you want to learn about AWS, there are a lot of resources, and you wonder why a lot of an issue that has come up a lot for companies that do not want to use the AWS cloud is that they don't have personnel or they don't have people trained to be able to use that to be able to use the platform. So as much as possible, AWS is even sponsoring organizations to train people so that if the company has the pool or the company has talent to be able to use that AWS resource, then that means they maintain the large market share. That means that they have more people using their resources. So training too is also another issue. You would need to train someone to be able to use whatever service or whatever resource it is that is inside the cloud. So that could also be seen as an disadvantage. Okay, so please, Ruben, is that okay?
Yeah, thank you very much.
You're welcome. All right, bye, guys.
Bye-bye.
Don't forget to post the video.
The video.
Bye.
Okay, I'll post it right now.
I gave tea. All right, thank you, Akosia. See you God willing tomorrow.
All right, bye, Ma.
Bye.